So we're going to start by taking a look at another RxJava example. This is one that is actually somewhat similar to portions of your assignment 4, except that we're going to be using RxJava features to implement the kind of image counter or image crawler example, as opposed to using the completable futures framework, which is what you did for assignment 4. And it's kind of fun to compare and contrast them in terms of how they're similar, how they differ, and so on, because one uses completable futures and the other, of course, uses RxJava. So let's take a look at the main program. This just goes ahead and parses the command line arguments and then creates a new image counter object that will go off and do the computation. So if you go to the image counter class, this class will be used to concurrently count the number of images in a recursively defined folder structure using a bunch of different RxJava features. And much like your assignment, the root folder can either reside locally in the file system or remotely in the web, just like a web page traversal. So let's take a look at some of the fields we have here. We have something calledmunique IDs or URIs. That's a concurrent hash set. And we use that to see if we've already visited a URI, so we don't visit it more than once. We also have a field called M0, which is just a single that is going to return 0. And we use that to simplify some of the code later, as you'll see. Here's the constructor for image counter. We go ahead and we get the root URI. And again, that'll either point to the file system or it'll point to a web page, depending on how you set the options when you run the program. And then we go ahead and call a method called count images, which gets to be kind of the main entry point into the recursive traversal, starting at the root. And we pass in the root URI and an initial depth of 1. We then call the blocking get method, which basically, as the name implies, blocks until all the computations are done and returns, in this case, a count of the total number of images that we're seeing. And then we print those results out. Here's the count images method. As you can see, it returns a single of type integer. And this is very similar to a completable future. So a single and a completable future have a lot of things in common, as we'll see in a moment. This method starts out by doing some sanity checking. It checks to see whether or not the depth is greater than the max depth. It also checks to see if we've already seen this page before. If we have, we skip over and return M0. If we've exceeded the depth, we also return M0. And that's why we define M0, just to have an easy way of returning a single that's a 0. So that's just kind of getting those things out of the way. Then we go ahead and call a helper method called count images async. And what that'll do, as we'll see in a moment, is that asynchronously crawls and counts the number of images on this page, and it'll crawl the hyperlinks accessible via this page and count the number of images reachable from those hyperlinks. And it gives back a single, and we use the do-on-success method, which will just print out some diagnostic information depending on whether we succeeded or failed. If an exception is thrown, this will not be called. If an exception is not thrown, this will be called. Here's the count images async method, and this basically does the bulk of the concurrent processing, kind of gets things going. So it does some really cool things. The first thing it's going to do is it's going to get the start page asynchronously. And you can see here that we use a var. This is Java, I believe it's Java 10 syntax. So you don't have to give the explicit type. The type is actually single of document, but we just use a var in order to be able to let the compiler deduce the type we're trying to use here. This is a feature that is very popular in other languages like JavaScript. So we're going to get the start page, and this will come back as a single, and that means that this will run asynchronously. And here's what get start page does. As you can see, what it does is it uses the from callable factory method to get the page at the page URI, and it's going to go ahead and have this computation run in the common fork join pool. And here's what this looks like. Here's a little helper method that I wrote just to make this cleaner and easier to work with. What we're going to do is we're going to go ahead and say, subscribe this computation for this single on the common fork join pool and make that be the thread pool that we're going to use to run the computation on. And so this uses the interesting compose method, which is kind of a way of defining your own operators, if you will, in RxJava. And that will then go ahead and make sure that this page download operation runs asynchronously in a background thread from the common fork join pool. So that's what start page does. So that'll start things running asynchronously. Now, what we get back here is this single. And as you can imagine, a single is very much like a completable future. So then what we do is when that page has finished downloading, the single will become triggered. And so the following operations can then run in parallel. And you can see that we're going to use this page single in two places. We use it here and here. And so both these operations will be able to go in parallel for reasons we'll disclose in just a second. So the first use of the page single is to get the images in the page. And that is, as we'll see, is going to run asynchronously. And the reason that that's going to run asynchronously is we go ahead and compose it with the common fork join pool. So this is going to run asynchronously, and you'll see what get images in page does is that simply goes out and uses some JSoup mechanism. JSoup is a parsing library that parses HTML content. And it's going to go ahead and look for all the images, the image elements on the page. So it's going to basically come back with an elements type, which contains all the images, the tags of the images. And then we're simply going to go ahead and return the count or the size of that elements collection. So this computation runs in the background and figures out the number of images on the page. Here's the other asynchronous computation. This one's going to go ahead and do a flat map and do a crawl links in page. And crawl links in page, as we'll see, is going to also need to run in the background. So we're going to compose it with the common fork join pool. So let's go ahead and take a look at crawl links in page. And you can see crawl links in page returns a single integer. And what it's going to do is it's going to take the page that's passed, and it's going to use the from iterable factory method to go ahead and get all the hyperlinks that are on this page. So we use the JSoup page select method, and we tell it to go find all the hyperlinks. So we get back a collection, which is basically an elements data structure. And then we use from iterable on that collection, and that turns it into an observable that emits elements. So basically what we're getting here is an observable that will emit all the hyperlinks on that page. We then go ahead and use the flat map concurrency idiom that we've talked about many times. And what we do is for each hyperlink on the page, we omit that hyperlink. This is what's called the inner publisher. So we omit that hyperlink. And then we say, do the following in the background in a pool, in a thread from the common fork join pool. And what we're going to do is for each of these hyperlinks, we're going to go ahead and call the count images method recursively. Remember, count images is this method that we started out with up here as the initial entry point for the first hyperlink. And that's going to check to see if we've exceeded the depth, and it's going to check to see if we've already seen the link. And then it's going to recursively call count images async. So what's happening here is that for each URL that we've got, we're going to go ahead and recursively call the count images method with that hyperlink passed in and an increment of the depth by 1. So all those different computations, all those calls to count images are going to be running in different threads or in threads in the common fork join pool. So all this computation is going to be taking place in the background in the common fork join pool running asynchronously. And then we convert this back to an observable because this call here returns a single. So we convert that to an observable. So we end up with a flat map returning an observable of integers, which are all the things that have been downloaded. So these are basically the counts from the different hyperlinks. And then we go ahead and use the reduce terminal operation to sum up all those counts. And we end up with a single count, which is a maybe, because there might not have been any links on the page. So this actually may create nothing whatsoever because there could be a page with no hyperlinks. So whatever we come back with, we get a maybe. And if the maybe has a value, that's the sum of all the elements that are computed from the hyperlinks on that page, so that'll get returned. But if there's no hyperlinks on the page, then we say return 0 as the default if that observable is empty, or if that maybe rather is empty. So that's how we get the data back from the crawl links in page method. And as you can see, that runs in the background in this pool of threads. So these two operations both go concurrently and asynchronously. And then we're going to call the combine image counts method. And as you can see, what that does is it uses a funny name. This is another one of these interesting names in RxJava called zip. And zip is basically, it's kind of the equivalent of then combine in completable futures, where you wait until both of the parameters passed in finish. In this case, there are 2, but you could have n of them. We have 2 of them. We wait till they're both done, and then we go ahead and sum the results. So that's essentially the main control flow for this code. And we've looked through all the different examples here. And so hopefully this will give you a nice sense of how you can use RxJava in order to be able to crawl recursive directory structure or recursive web page hierarchy and then print the results out. So if we go ahead and run this program, you can see what it's going to do. It's going to actually crawl a directory that's on my website, and it'll give us some interesting diagnostics. Notice, by the way, it tells you the threads where the computations are taking place. So in thread 24, we're going to actually go and revisit a page we've already seen. So we ignore that. Likewise, we also are going to keep the depth limited to 2. So if we get beyond 2, we're going to ignore that. And then what we're doing here is, you can see in the different threads, we found 7 images in this URL. We found another 7 images in that URL. And then we combine those together. So we found 22 images in total in the images folder. And then the final thing we have here will be the main thread, the caller thread, which says at depth 0, in other words, when we start off, we have 22 total images that are reachable from this particular directory. And if we were to go poke around there, you'd see that that's indeed correct. So it's pretty cool. So that's an example of how to use RxJava to do this type of computation. What we're going to do next is we're going to take a look at how to do this with completable futures, and that'll give us a chance to compare and contrast the 2 approaches. All right, so let us go and see if we can find